Place oxygen cylinders a safe distance from the burning operation. Protect them from heat, sparks, and hot slag. Use an oxygen hose large enough to ensure maximum flow to the burning bar. After the oxygen system is set up, leak check all fittings. Do not use any oxygen system if there are any leaks. When operating burning bars, always wear proper fire-resistant protective clothing. Oxylance recommends aluminized Kevlar. For face and eye protection, use a full face shield with a minimum of shade 5 lenses. You should also wear goggles or safety glasses with side shields under the face shield. Provide adequate ventilation or provide the operator with a fresh air breathing system. Never use oxygen for breathing. One of the technical questions that Oxylance has to answer almost daily is what type of filter should be used with a lung-powered breathing mask. We cannot answer this because we don't know what fumes are being produced from the material being cut. For optimum safety, the operator should be provided with a fresh air mask. Set oxygen pressure to required pressure, 90 to 150, depending upon the material being cut. When the operator is ready to begin cutting, he inserts the burning bar into the holder. The end of the bar with the bent crimp goes in the holder. Make sure the bar goes all the way through the rubber grommet and seats in the base of the holder. Lock the bar in place and slowly open the oxygen control valve to purge the hose and burning bar. Never attempt to ignite a burning bar that has no oxygen flow. Turn the oxygen control valve off and have an assistant heat the tip of the burning bar with an oxyacetylene torch until it is slightly molten. Slowly open the oxygen control valve to ignite the burning bar. As soon as the bar is ignited, you can begin cutting. Portable liquid oxygen cylinders will not produce the required volume of gaseous oxygen to operate burning bars. Special procedures are required in order to safely use liquid for burning bars and other high-volume applications. Typical liquid cylinders hold 45 to 55 gallons of liquid oxygen. When the liquid is fully vaporized, these cylinders produce 4,500 to 5,500 cubic feet of gaseous oxygen. The internal vaporizer in a typical liquid cylinder will vaporize 350 cubic feet per hour, or about 5 cubic feet per minute. Burning bars require 25 to 100 cubic feet per minute, or 1,500 to 6,000 cubic feet per hour. Liquid cylinders rely on an internal vaporizer to produce gaseous oxygen. Ambient temperature affects the output of the internal vaporizer. A liquid cylinder sitting in the sun will build more pressure than a cylinder sitting in the shade. Ice formation indicates the system is being overdrawn. Flowing water over the cylinder does not increase the output. Water removes the ice, which is the only visible indication the system capacity is being exceeded. Ice forming on the regulator and hose is a safety hazard. An external vaporizer must be added to prevent injury or damage to equipment. This is a 5,000 cubic feet per hour external vaporizer. Output of the vaporizer is determined by the length of the fins and tubing. The lower manifold hoses supply liquid to the vaporizer. Second manifold is provided to manifold cylinder vents. Manifolding the vents allows pressure to equalize in the cylinders, allowing them to draw down evenly. All cylinders must have the